Okay, welcome everybody. We're going to be doing the first unit of the course. Welcome to chemistry, and we're going to be going through some basic things in the beginning, and then we'll get getting into the course. Um, it's going to be a tough nut to crack. There's a lot in this course to go through, so we'll take it step by step and do your best to understand everything. Ask questions to your teacher, ask questions to me, and go along with it. And I think you'll just be fine. So first slide along here is just what chemistry is. It's the study of matter. It's the study of stuff, what it's made of. Also along the lines of the changes that take place and the energy that's involved in this change. Okay, and some major divisions that you want to be along with this is maybe you get into chemical engineering, which is the chemistry and physics put together in a science. Organic and polymer chemistry is the compounds of carbon. You're studying, living things would be in a biochemistry type of thing. Nuclear would be changes in nucleus, radioactivity, nuclear power, things like that. Analytical stuff, big field these days in how we test things, and some crime solving would be for forensics. Just some big ideas, and these are ideas that we're going to be hitting throughout the whole course. And these are like these threads that kind of like are interwoven throughout the whole course, and some big ideas that you'll be seeing here a little bit. And it's important to understand these. As far as taking notes on them right now and knowing exactly what all of them mean, you might not be know that, but we'll go back and go over them. Okay, the first one is really attractions. All right, and attractions are a big part of the course because that's what holds everything together. And the attractions and the structure of how those particles get together dictate what the properties and behavior are going to be. All right, positive matter and negative matter will attract each other, okay, and like charges are going to repel. And this is pretty much a rule for the most part. This is going to happen. You're going to see this, and this is responsible for keeping things together. Okay, nature itself naturally tends to find a lower energy state or a lower energy position. And the only way to do this is by releasing potential energy or energy that's stored in the system. Okay, nature also seeks to become more random in its state. So this helps to explain some of the behavior that we're going to see. All right, as far as matter and energy, they're never going to be created. Basically, we're stuck with the matter and stuck with the energy that we have in our universe, and they simply just change the form. So nothing can really disappear into magic or reappear like you see in magic tricks. We have to be able to account for this. Most of the time, you can even think about this as being the conservation of money. Again, if you think about money, money can flow from one place to another, but generally, it's not going to disappear and just be created out of nothing. Okay. Knowledge comes from observations and comes from testing things and getting our data from testing, seeing what it means, retesting, running experiments. And then what we do is we create models to try to explain what these things are. So just the idea of an atom, when we think of an atom as a little circle or a little ball, is really just a model of what we think atoms look like. All right, so none of the models are perfect. We continue to modify them all the time and make them better every time. Okay. All right. So basically, what do we when we talk about the study of matter? What are we thinking of? Well, generally speaking, anything that has mass. So anything that has you can touch, feel, hold, solid objects, small objects, large objects. These have mass. Generally in grams or kilograms. Again, it doesn't have to be in those two, but generally in grams you'll see this. And it has some type of volume, right? Milliliters, cubic centimeters, liters. Generally, you could do it this way. Just keep in mind that the centimeters cubed is a cubic unit, and milliliters and liters generally, milliliters would be equivalent to a cubic centimeter. But again, it depends on what you're using. Are you using a solid object, you're using liquids, and so on. Okay, really important. Matter can be broken up into two things. We can break it up into pure substances. Now, pure substances, the word pure should really trigger you here. Okay, pure means it's made of nothing else. It's only made of one thing. Okay, and when we talk about, and if I get my pen together here quickly, my pen, I'm going to go yellow. Okay, when we talk about uniform, we really mean uniform meaning even throughout, right? It's the same throughout. Okay, and we use the term definite composition. Definite meaning set. Okay, and I know I wrote that here, and composition means what it's made of. Okay, so you can think of that saying what it's made of. So if you're adding little sentences to your notes, this is going to go along, of course, with your notes. You can think of it like that way. All right. All right. So if we keep going along, so substances are going to have chemical formulas to them. All right. So generally speaking, if you take a look at one type of this kind of substance, would be elements. Okay. And you've heard of elements before. One type of pure substance. Okay. An element is generally represented by a circle. You've probably seen these so many times. Elements as these little balls, these little circles. Okay. And a good example of the neon. So this would represent the neon atom. Okay. And elements don't necessarily have to have one atom. Sometimes elements can actually be connected in groups of two atoms, but two atoms of the same element. And this is sometimes called something that's diatomic. So if I go back to my pen for a minute, I can call this, check my colors. Sorry about that. Yellow. We can call this diatomic. So diatomic, meaning that you have these, two different atoms. Sorry, the same atom. I'm sorry, same atom bonded to itself, but still the same element. So this would be a Br here, and this would be a Br here. Right, so you can think of it like that. Now, compounds, on the other hand, would also be a pure substances, but in this case, you would have two different elements bonded to one another. So this is a little different. So in this case, you'd have a compound like that, where you'd have two different elements. So notice that in an element, that particular atom remains the same. So you have a single element, but in a compound, you're going to have different elements that are combined together. Okay, and you can see that has a formula, right? So just like neon would be the formula for this element, and Br2, the two meaning that there's two bromine atoms, would be for two atoms of that element. Notice that the formula H2O, that I'm sure you're familiar with, means something, right? It means that there's two H's. Here's one of the H's, and this is the O here. That would be the oxygen. So this is set. Okay, this formula is going to be set, which means water always has this formula. Okay, so when you go back to the beginning here, matter that is uniform and definite, a definite composition, water is always made of these three atoms together. All right, and that's going to be important. Again, this atom is this little particle. All right, so that's a big deal here. Not a big deal. All right, so next thing is matter can also be not only just a pure substance, but it also can be a mixture. All right, and a mixture is a case where you don't have a definite composition. Your composition is actually a variable in this case. So in this case, you're going to have where you're going to be variable. Now, variable just simply means that something can change. All right, so if this composition can change and what it's made of changes, then you have something called a mixture. Iced tea is a good example of this. If you went to a diner or you went to a restaurant and you asked the waiter or the waitress, can I have some iced tea? They would ask you what kind, right? They would be going through all the different types of iced tea it could be there. I mean, what could this be? What kind of iced tea would that be? And you'd be wondering what you were getting. All right. Again, seawater maybe versus lake water. Okay. Is definitely different things in seawater than in lake water. All right. So if you think about it, do you like mint green iced tea? Do you like cherry black tea? I mean, what's your favorite iced tea? It depends on what you're doing. So just to review this slide quickly. So you have matter. You have two different types of matter. We're going to have pure substances. We're going to have mixtures. Okay. Pure substances are going to be pure. One type is called elements. Okay. One type of matter is called elements. The other type called compounds. And again, these are going to have chemical formulas where mixtures can vary. Again, the formula, what I'm speaking of is the symbol neon, the symbol here Br2, the formula H2O, which tells you this set composition. Okay, so no sweat, nothing too crazy here. All right, so what we're going to do is take those two types of matter, the pure substances, and look at them a little closely. All right, so we're going to take elements, okay, and really what elements are is they're going to be building blocks of our matter, right? They're going to be building blocks of all matter. So really, all matter is made up of a type of element. All right, and that's going to be the important part of understanding this part. Make sure I get my pen. All right, so building blocks of all matter, think of it as building blocks. Okay, and again, most of our earthly elements eventually came, originally came from space. All right, and we get the elements from exploding stars. When you had the Big Bang, we eventually, everything kind of formed into planets and galaxies and stars. And generally, when we get these particles coming together, that's how the elements were formed. We'll be getting into this in the class a little bit about the interesting people that were able to solve these problems of what the elements were. It's kind of a crazy story and an interesting story. Okay, so really, what's an element? An element is just a type of matter where you cannot break it down any further. You cannot do it. All right, so by a chemical reaction. So that particle, that atom, is set by nature, and there's no way you can break it down anymore. And once you reach the beginning, you have an element. Okay, and that's the word elementary. It means basic. Okay, so you can't break that down any further. Okay, when we talk about a neutral atom, we're talking about particles that don't have an electric charge to them. So your number of and the same number of protons. So let's just say you had an atom of hydrogen. Okay, if you had an atom of hydrogen, that hydrogen atom would have one proton, positive, and would also have one electron that would be negative, and they would cancel, and you'd be neutral. So that's where that comes from. That's the word neutral comes from, is when you have the same number of protons that you do electrons. I'm hoping that you know what protons and electrons are. We're going to go through it in a little more detail as we move on the course, but at least you know what neutral means. Neutral means no charge. Okay, how do we usually represent atoms? As these little circles. If you had two of them, you'd have two atoms. If you had three of them, you had three atoms. Okay, and that's how we usually represent them. Again, more about this as we move on. Okay, you know this well. This is the periodic table, and the periodic table is a listing or a chart where we see all the elements. Okay, and they're listed in order of atomic number. So this little one at the top really tells you what the atomic number is, and that follows this crazy little I should say geographical shape, but it's kind of a chart shape. And there's a reason for all of this, and we're going to be going through all of it. But at least you can see. Now, there's three main regions of types of elements. Okay, and you'll see here is one type is called elements. So this big gray area here are called metals. Okay, and there's a reason why we call them metals, and we'll get into that. Also, worthy to note that at element 57, you would go down here and follow that row, and then from 89 to 103 would follow that row. So you can see there's like a little detour. So once you finish 71 over here, you come back up and follow 72. And there's a reason behind all this. Again, nothing to worry about. You just want to know the basics here. Okay, once you start going across to the right, you then end up with something called metalloids. So you see the word metal still in there, but you have these metalloids. Sometimes they actually call these semi-metals. And these elements have properties of metals, but they have properties also of non-metals. So this, again, this orange region, so this yellow regions would be your non-metals, metals here, metalloids somewhere in the middle. And think of this as almost like a transition, right? You're going to transition across here from the metals to the non-metals. You're not just going to go from metals directly to non-metals. There's this, this gray area, quote unquote gray area, or this blue area where the elements can be somewhat like the metals on the left and somewhat like the non-metals on the right. And they have some interesting uses and things like that. Sometimes they do call them semi-metals. Okay, so really it's kind of easy. You really have just two main types, the metals and the non-metals, and we'll get into this more a little bit more later on. But you want to have a good be familiar with what the regions are, the basic non-metals versus metalloids versus metals. Okay, and again, as we move along, you'll be better with this. Okay, phases. Okay, the phases of the elements are in this way where you predominantly have your gases on the right. I have to get my pen back again. On the right side, you're going to have your gases. Okay, so your nitrogen, your oxygen, your fluorine, chlorine, you're probably familiar with those elements as being gases. Of course, nitrogen, oxygen, we breathe. Okay, don't forget hydrogen back here, because hydrogen also is a gas. Okay, and don't forget also that the noble gases here are all gases as well. Okay, want to make a note definitely of bromine and mercury. Both of these elements are going to be liquids. It's the only two liquids on the table, and you can see everything else is a solid. Okay, and I just want to make one more note about hydrogen here. Hydrogen, make sure that you remember that hydrogen is actually falls into the category, sorry, it's right here. This is actually a non-metal. I know it's listed on the left, and I know it has the same color here. I just want to make sure you guys, I make a note of that on this presentation. Okay, good job. All right, so you want to be able to, again, get familiar with your phases. You're going to eventually have to know them. It's kind of easy to know the gas. You can just think of this as an upside down L over here, including chlorine and helium and hydrogen, and you can kind of get across on that. Just elements you've seen before in your life. Aluminum is someone, is a sample of an element we use a lot. Chlorine, if you take a look at chlorine, you can see this very small. You can see this greenish haze that's in here. That's the gas chlorine. All right, that's what that haze is. And again, it's worthy to note this. Again, we'll see this a little in class. I might put up a video of this, where Humphrey Davy, he was one of the few. He was one scientist who used to play with do a lot of demonstrations, and he actually co-discovered a bunch of elements in the periodic table by using electricity to actually break up compounds. And he would break up compounds into these new substances. And he noticed that these substances were brand new. No one had ever seen them before. And he was instrumental in finding several elements in the periodic table. Okay, and just as a little aside to you, just to show you that your cell phone itself, your iPhone, has many different elements in it, and some of them are kind of like strange ones, like ones you never heard before, like indium and yttrium and terbium and europium, and a lot of these have to do with the electronics and how the screen reacts to the energy. You have some indium in here, and dysprosium and gallium, and some of the ones you might are the lithium. The lithium-ion batteries are a hot topic right now. Tin. There's also some gold. I mean, it's not on this list, but if you ever look at the gold contacts of a lightning port of your iPhone, you would see these gold contacts. So again, what's the main idea about this? The main idea about your elements is to go back. I'll go back to that slide really quickly. Is just to make sure that you're very good being able to recognize what an element is. It's these three things. Okay, you cannot break it down any further by a chemical reaction. Again, we'll talk about chemical reactions, but you can't. That's the idea, is not breaking it down. You're one type of atom. Okay, each element has its own type of particle, and those particles are going to have the same number of protons. Okay, and they're going to be neutral, which means they have the same electrons. And I said I use the example of a hydrogen having one proton and one electron, and that's what defines what a hydrogen atom would be. Okay, and you're going to find them on the periodic table. All right, so that's really the first 5 or 6 slides, everybody, up through elements. Okay, again, not a big deal. It's a good start. Okay, and then again, the next presentation will be continuing from starting from chemical reactions. Okay, hope to see you soon. Bye bye.